Good morning, colleagues. Today we are going to solve exercise 3.25 from the book Fundamentals of Electrical Circuits. Sadiku. This exercise tells me that by applying nodal analysis and using MATLAB to determine the tensions of the nodes in the figure, we observe that previously the nodes have already marked the tensions that we have to calculate B1, B2, B3 and B4. Now the first thing we have to do is mark the directions of the currents where they go. Guided by a visual analysis that we see using the reference sources. We see how here they are putting a reference node that is connected to ground. All that common point is worth 0. This reference point is a good one to demarcate the currents that circulate. I'm going to start here. Here the current comes 4 amps and rises to this point, and from here it has to find its way somewhere. I say that part of it, since I don't see any source anywhere, I say that part of the current comes from here, in this direction, and the other part of the current comes from here. This current that comes from here follows the path until it reaches this point. In other words, one part is going to come here and the other part is going to come here. So I'm going to mark this current and this one that comes over here. The one that comes out of this point now. This current that comes from here. When I got here it turned out that one part comes from this side. And the other part comes from this side, This current that comes from here and this one that comes from here, come together at this point. Therefore one comes here taking the earth as a reference. Well, we have already marked the currents that circulate through the circuit. I have to give you names then. Well, I'm going to call this the current I1, which would be the same as this one would also be the cognitive one. The one that comes over here, the current N2 is this the current N3 is this, the current N4 the one that comes here. The current, well, this one I'm going to call N5, this one that's here I'm going to call it 6, and this one that's here I'm going to call it N7. Okay, so we start at node 1. Node V1. Hey, it's here. I'm going to look at the currents that are going to be equal to the currents that come out and the currents that come out, the current N1 plus the N2 N1 plus the N2. That's going to be equal to 4 amperes, okay? So the current N1 has it here is going to be equal to a V1 minus V4. About 20 ohms. What is here is the current, and the current N2 plus the current N2 that comes from here would be V1 V2 over a man equal to 4 amperes. So, if I separate the variables versus 1 over 20 minus V4 over 20 plus versus 1 over 1, then it would be versus 1 minus versus 2 over 1, which would be V2 equal to 4. Hey, well, if I operate V1 with V1 I will have 21 over 20 volts 1. Less a V2, and I already have V1, I already have V2 I have to operate. The last variable I have left would be versus 4 would be minus versus 4 over 20. That's going to equal 4. Ready. Then the voltages V1, V2 and V4 have already been lost. Now I see that there are two denominators here and sin 20. Then I multiply both sides of the equal by 20. I would stay here, Well, I would stay. I'm going to put here 21 volts 1 times 20 would be minus 20 volts. 2 minus V 4 equal to 80 would be equation number 1. I'm going to delete this here and I'm going to do equation number 2. A. In the at node V2 we observe that the currents entering the N2 and the ones that come out of the N3 plus the N4 and 3 and 4 come out N4. Therefore the current N2 would be versus 1 minus 2 over 1. Over 1 is going to be equal to 43, but the current and 3 volts 2 over 8. The current and 4 would be P2 minus 3. About 10 ohms. Okay, so V1 over 1 is equal to B1. B2 V1 over 1 as V1 minus V2 over 1 as V2 equals V2 over 8 plus V2 over 10 in V3 over 10. Hey. Okay, I'm going to go to the other side of the same. I'm going to get that. Well, I'm going to move all of this to the right, toward the left. What a pity. It's going to be P1 P2 minus V2 over 8 minus V 2 over 10 plus V3 over 10 minus minus plus. All of that is going A0 V1 as alone. So I'm going to put V1 here V2 or but everything that has V2 is going to give me minus 49. You can verify it over 40 V2 V3 would be more V3 over 10. Equal to 0. I'm going to multiply by 80 to eliminate that denominator. Good. Or well, I'm going to multiply by 40 by 40. This is going to leave me with 40 volts 1. Minus 49 V2. Hey. Plus 4. V3 equals 0. Hey. Well, this would be my equation. 2. At node V3. And I have here at this point the currents that enter are going to be equal to Y4 plus Y5. So the Y4 plus the Y5 equals the Y6, so not V3, the Y4. The one that comes here would be V2 minus versus 3 over 10 V2 V3. About 10 more. The 45 volts 4 minus V3. As you connect it down V4 minus V3 over and it's also equal to the current N6 and the current N6 as the one that comes over here would be V3 over 20. Okay, so it would be V2 over 10 minus V3 over 10. V4 over 10 minus V3 over 10. Hey. This is passed to the other side. It would still be negative V3 over 20 equal to 0. Well, V2 out of 10 V. 3 out of 10 and 4 out of 10. 3 out of 10 and less. V3 above all. That's here. Hey. Let's go operate. Hey, whatever has B2. B2, only this variable would be V2 over 10. Whatever has V3 would be this. This and this would be minus V3 over 4 plus V4 over 10. I'm going to multiply everything by 40. This equals 0. Everything times 40 is going to eliminate the denominator. Here I want it. I'm going to put it. I'm going to download this. I'm going to put it here. It would be 4 V2 and 10 V3. Plus 4 volts 4 equals 0. Okay. Okay. Now we're going to work on node V4. On node V4. Hey. It would be 123. It would be. Here we observe that the currents that enter there are 1 and 1. It's going to be equal to the current that comes out, which would be the Y5 plus the Y7. The Y1 as V1 minus V4 over 20 is going to be equal to the Y5 the Y5 volts 4 minus versus 3 V3 out of 10 plus the 47, the 17 V4 out of 30. Well, we start operating. It would be V1 over 20 minus V4 over 20. It's going to be equal to AV4 over 10 V3 over 10 V4 over 30. Hey. I'm going to go to the other side. There will still be V1. About 20. Minus V4 over 20. Minus V4 over 10. Now I'm passing all of this to the other side of equal AV3 over 10 minus V4 over 30 equals 0. It exceeded what one has would be V1 out of 20. Hey, whatever has B3 over 30 over 10 kilopascals and whatever has V4. This one with this one with this one is going to give me minus 11 over 60 V. Now I'm going to multiply by 60. And the equation is going to stick with 60-20 would be 3 volts 1 plus 6 volts 3 minus 11 V4 equals 0. 4. Hey, let's notice that we have 4 variables B1, B2, B3 and B. So for the first equation I'm going to delete it. All this. The first one tells me what it 21 minus 20 in B3 because there are no V3 and minus 20 space 20 space because there is no V3 and minus 1. Then semicolon to move to the next row 40 to 49. 40-49 space. There is no V3 and there is a positive 4 no versus 3 and there is what there is no V4 would be 4 and 0 4. And 0.4. A. For the next one there is no versus 1, but 6 volts 204 10 0 4 minus 0 1 4 1 0 and 4 for 4 semicolons. And the fourth row 3 0. Because there is no V. 2 and 6,306,306 minus 11 minus the V matrix. You already did it for the matrix V 83 0. So 80 semicolon 0 semicolon 0 0 in the solution. Variable is going to be to control the sales. Hey? Okay. These are the values B1, B2, B3, 2552, 21 4, 14. I'm going to put it here. 25.52. B2. Hey. 22.04. B3 14.84. And V4 15, 0. Well, those are the voltages that the exercise asks of me. Determine the tensions in the nodes. See you